industry professionals often express concerns regarding the dependability of outdoor bus duct, especially when subjected to demanding environmental conditions. Numerous instances of outdoor bus duct malfunctions have been thoroughly documented, encompassing failures involving various prominent manufacturers. Outdoor bus duct is vulnerable to extreme temperature variations, humidity, ultraviolet radiation, and other environmental elements that have the potential to undermine its overall integrity. While substandard installation procedures can worsen existing problems, failures have also been observed in systems that appear to be correctly installed. Based on the available evidence and shared experiences, it is logical to conclude that outdoor bus duct installations are generally susceptible to failure. Firstly, environmental stress can significantly contribute to the problem. Severe outdoor conditions can degrade insulation, promote corrosion, or trigger issues related to thermal expansion and contraction. Secondly, mechanical damage poses a threat. Wind, snow, and other external forces can inflict damage on the bus duct itself and its supporting structures. Thirdly, moisture penetration is a concern. Water infiltration can lead to the deterioration of insulation and the occurrence of electrical faults. Fourthly, installation errors can heighten the risk of failure. Examples include improper grounding techniques. If feasible, it is advisable to relocate essential electrical feeds indoors or explore alternative distribution methods such as underground cabling. If the use of outdoor bus duct is unavoidable, consider implementing enhanced protection measures such as weather-resistant enclosures, surge arresters, and robust grounding systems. Implement a comprehensive inspection and maintenance program to promptly identify and address potential issues. Design the electrical system with redundancy to minimize the impact of a potential bus duct failure. The location and climate of the installation site can considerably affect the probability of failure. The quality of the bus duct manufacturing and installation significantly influences its reliability. Appropriate engineering practices and diligent supervision are indispensable to guarantee a reliable installation. It is critical to consider the materials used in the bus duct's construction and their resistance to environmental factors. Aluminum and copper are common conductor materials, each with its own advantages and disadvantages regarding corrosion resistance and conductivity. The insulation material surrounding the conductors must also be able to withstand temperature fluctuations, UV exposure, and moisture. Regularly inspect the bus duct for signs of corrosion, cracking, or other forms of degradation. Pay close attention to joints and connections, as these are often the most vulnerable points in the system. Thermal imaging can be a valuable tool for detecting hotspots, which may indicate loose connections or insulation breakdown. Ensure that the bus duct is properly grounded to prevent electrical faults and protect personnel. The grounding system should comply with all applicable codes and standards, such as the National Electrical Code, or NEC. Consider using surge arresters to protect the bus duct from voltage surges caused by lightning strikes or other transient events. These devices can help to prevent insulation breakdown and equipment damage. The supports and hangers used to mount the bus duct must be able to withstand the weight of the system, as well as any additional loads imposed by wind, snow, or ice. Regularly inspect these supports for signs of corrosion or damage. In areas with high winds, consider using wind bracing to prevent the bus duct from swaying or vibrating excessively. Proper sealing of all joints and connections is essential to prevent moisture from entering the bus duct. Use a high-quality sealant that is compatible with the materials used in a bus duct's construction. If the bus duct is exposed to direct sunlight, consider using a UV-resistant coating to protect the insulation from degradation. Install a monitoring system that can detect changes in temperature, humidity, or other environmental conditions within the bus duct. This can provide early warning of potential problems and allow you to take corrective action before failure occurs. Develop a comprehensive maintenance plan that includes regular inspections, cleaning, and testing. The frequency of these activities should be based on the environmental conditions at the installation site and the criticality of the load being served by the bus duct. Ensure that all personnel who work on the bus duct are properly trained and qualified. They should be familiar with the manufacturer's recommendations for installation, maintenance, and repair. Keep detailed records of all inspections, maintenance activities, and repairs. This information can be used to track the performance of the bus duct over time and identify any recurring problems. If you experience a bus duct failure, conduct a thorough investigation to determine the cause. This will help you to prevent similar failures from occurring in the future. Consider using a backup power source, such as a generator or an interruptible power supply, to provide power to critical loads in the event of a bus duct failure. This can help to minimize downtime and prevent data loss. When replacing a failed bus duct, consider using a more robust system that is better suited for outdoor applications. There are many different types of bus duct available, each with its own advantages and disadvantages. Consult with a qualified electrical engineer to select the best system for your specific needs. When installing a new bus duct system, ensure that it is properly designed and installed in accordance with all applicable codes and standards. Use qualified contractors who have experience installing bus duct systems. Conduct regular training sessions for maintenance personnel to keep them up to date on the latest technologies and best practices for bus duct maintenance. Develop a contingency plan that outlines the steps to be taken in the event of a bus duct failure. This plan should include procedures for isolating the failed section of bus duct, restoring power to critical loads, and repairing or replacing the bus duct. Regularly review and update the contingency plan to ensure that it is still relevant and effective. Consider using predictive maintenance techniques to identify potential problems before they lead to a failure. These techniques can include vibration analysis, infrared thermography, and oil analysis. Implement a quality control program to ensure that all bus duct components meet your specifications. This program should include procedures for inspecting incoming materials, monitoring the manufacturing process, and testing finished products. Consider using a bus duct system with a built-in monitoring system that can provide real-time data on the performance of the system. This data can be used to identify potential problems and optimize the performance of the bus duct. When selecting a bus duct manufacturer, choose a company that has a proven track record of providing reliable products and excellent customer service. Obtain references from other customers and check the manufacturer's warranty policy. Consider using a bus duct system that is designed to be easily maintained and repaired. This can help to reduce downtime and maintenance costs. Ensure that the bus duct system is properly labeled and identified. This will help to prevent confusion and ensure that maintenance personnel can easily locate the correct components. Develop a detailed set of operating procedures for the bus duct system. These procedures should cover all aspects of the system's operation, including startup, shutdown, and emergency procedures. Regularly review and update the operating procedures to ensure that they are still relevant and effective. Consider using a bus duct system that is designed to be energy efficient. This can help to reduce energy costs and improve the overall efficiency of the electrical system. Implement a program to recycle or dispose of old bus duct components in an environmentally responsible manner. This can help to reduce waste and protect the environment. Consider using a bus duct system that is designed to be compatible with your existing electrical equipment. This can help to simplify installation and reduce costs. Ensure that the bus duct system is properly protected from physical damage. This can include installing barriers to prevent vehicles from hitting the bus duct or using a ruggedized enclosure to protect the bus duct from the elements. Develop a plan for managing the risk of arc flash events in the vicinity of the bus duct. This plan should include procedures for assessing the risk of arc flash, implementing safety measures to reduce the risk, and providing training to personnel who work on or near the bus duct. Regularly review and update the arc flash risk management plan to ensure that it is still relevant and effective. Consider using a bus duct system that is designed to be flexible and adaptable to changing needs. This can help to extend the life of the system and reduce the need for costly upgrades in the future. Ensure that the bus duct system is properly integrated with the building's overall electrical system. This includes ensuring that the bus duct is properly sized to handle the load and that it is protected by appropriate overcurrent devices. Develop a plan for managing the risk of power outages caused by bus duct failures. This plan should include procedures for identifying critical loads, providing backup power to those loads, and restoring power to the entire system as quickly as possible. Regularly review and update the power outage management plan to ensure that it is still relevant and effective. Consider using a bus duct system that is designed to be easy to install and maintain. This can help to reduce installation and maintenance costs. Ensure that the bus duct system is properly supported and braced to prevent movement or vibration. This can help to extend the life of the system and reduce the risk of failure. Develop a plan for managing the risk of fire in the vicinity of the bus duct. This plan should include procedures for preventing fires, detecting fires early, and extinguishing fires quickly. Regularly review and update the fire risk management plan to ensure that it is still relevant and effective. Consider using a bus duct system that is designed to be resistant to corrosion. This can help to extend the life of the system and reduce the need for costly repairs. Ensure that the bus duct system is properly ventilated to prevent the buildup of heat. This can help to extend the life of the system and reduce the risk of failure. Develop a plan for managing the risk of electrical shock in the vicinity of the bus duct. This plan should include procedures for preventing electrical shock, providing first aid to victims of electrical shock, and investigating electrical shock incidents. Regularly review and update the electrical shock risk management plan to ensure that it is still relevant and effective. Consider using a bus duct system that is designed to be easy to inspect. This can help to identify potential problems early and prevent failures. Ensure that the bus duct system is properly protected from rodents and other pests. This can help to prevent damage to the insulation and other components of the system. Develop a plan for managing the risk of vandalism in the vicinity of the bus duct. This plan should include procedures for preventing vandalism, detecting vandalism early, and repairing or replacing damaged components. Regularly review and update the vandalism risk management plan to ensure that it is still relevant and effective. Consider using a bus duct system that is designed to be energy efficient. This can help to reduce energy consumption and lower operating costs. Reviewing NEC Table 310.15b16 can assist with ampacity adjustments based on ambient temperature and number of conductors. Proper torque of connections as specified by the manufacturer is critical, and using calibrated torque wrenches is essential. Regularly check for evidence of moisture ingress, such as water stains or corrosion. Verify that all weep holes are clear and unobstructed to allow for proper drainage. Ensure adequate clearances around the bus duct for ventilation and maintenance, as specified by the manufacturer and relevant codes. Periodically perform insulation resistance tests such as mega testing to assess the condition of the insulation. Maintain proper phase balance on the system to prevent overheating and premature failure. Use appropriate personal protective equipment, PPE, when working on or near the bus duct, including arc flash rated clothing, gloves, and face shields. Consider the use of ground fault protection to minimize damage in the event of a ground fault. This is especially important for critical loads. Ensure that all overcurrent protective devices are properly coordinated to minimize the extent of an outage in the event of a fault. Document all maintenance and inspection activities, including dates, findings, and corrective actions taken. This information can be valuable for identifying trends and predicting future problems. Before undertaking any maintenance or repair work on the bus duct, to energize the system and verify that it is properly locked out and tagged out. Follow all applicable safety procedures. Consider using a bus duct system with a modular design to allow for easy expansion or reconfiguration. This can be beneficial if your power needs are expected to change in the future. Ensure that the bus duct is properly sized to handle the maximum anticipated load, with sufficient margin for future growth. Consult with a qualified electrical engineer to determine the appropriate size of bus duct for your application. Consider the use of harmonic filters to reduce the impact of harmonic currents on the bus duct. Harmonic currents can cause overheating and premature failure. Ensure that the bus duct is properly supported to prevent sagging or distortion. This is especially important for long runs of bus duct. Consider the use of vibration dampers to reduce the impact of vibration on the bus duct. Vibration can cause fatigue and premature failure. Ensure that the bus duct is properly shielded to prevent electromagnetic interference or EMI with other equipment. Consider the use of a bus duct system with a low impedance designed to minimize voltage drop. Voltage drop can cause equipment to malfunction or fail. Ensure that the bus duct system is properly labeled to indicate its voltage, amperage, and other important information. Consider the use of a bus duct system with a remote monitoring system that can provide real-time data on the system's performance. This data can be used to identify potential problems and optimize the system's operation. Ensure that the bus duct system is properly commissioned after installation. This includes verifying that all connections are tight, that the insulation resistance is within acceptable limits, and that the system is operating properly. Consider the use of a bus duct system with a warranty that covers both parts and labor. This can provide peace of mind and protect your investment. Regularly inspect the area around the bus duct for any signs of potential hazards, such as leaks, spills, or debris. These hazards can increase the risk of fire or electrical shock. Ensure that all personnel who work in the vicinity of the bus duct are aware of the potential hazards and the safety procedures that must be followed. Consider the use of a bus duct system with a fire-resistant curtain to protect the system from fire damage. Ensure that the bus duct system is properly grounded to prevent static electricity buildup. Static electricity can damage sensitive electronic equipment. Consider the use of a bus duct system with a surge suppression system to protect the system from voltage surges caused by lightning or other events. Ensure that the bus duct system is properly protected from physical damage caused by vehicles, equipment, or other objects. Consider the use of a bus duct system with a seismic bracing system to protect the system from damage caused by earthquakes. Ensure that the bus duct system is properly maintained to prevent the buildup of dust, dirt, or other contaminants. These contaminants can reduce the system's efficiency and increase the risk of failure. Consider the use of a bus duct system with a self-cleaning design to reduce the need for manual cleaning.